in the motorcycle business, general mechanics, hydraulics, stuff like that, if you're in it to win it, you get up in the morning. So here it is, 5 a.m. And I'm going to show you how I apply the Moore Jigbore to Harley Davidson parts. And I think the sharp industrial machinists that watch this channel get a kick out of it. Probably a lot of people that are trying to make money on this stuff will get pissed off, and I've seen it time and time again. Now, the motorcycle business is a tough business, and in general, like power sports and stuff like that. But Harley Davidson is just like extra nasty when it comes to business. And I'm not kidding you, there's nothing like it. So anyway, all that aside, let's have a look at how I apply the Moore Jigbore to the Harley Davidson engine and other bikes too. Okay, here we go. And what do we have here is a Moore number 2 Jigbore. Now, what separates this from the Bridgeport is just rigidity, accuracy. This thing weighs 4,000 pounds and it's 8 feet tall. And its purpose is not a milling machine. It is to locate and bore holes. And the spindle design on this is designed for single point hole boring. But it also does extremely well with boring and facing heads. Now, this is a Wallhopter 5-inch automatic facing head, and you can use it for facing and boring. So this thing rotating in the spindle, I have a 40 taper in it now, but I put a more shank in it. This thing's like 30 pounds, and the Moore can handle it, and so can a number 2 heavy duty. This is a heavy mill, 5,000 pounds here. See, I can apply that in both the vertical attachment and, of course, the 50 taper horizontal. So what can I do with this thing? Well, the cases, I don't have any big twin cases that don't have the rest of the engine on it, are missing this part. You know, this is a unit. The big twins have the old style separate transmission. So, and there's a lip on one of the cases here. So if one of these cases, now what I'm talking about is like catastrophic repair of engine cases that are worth repairing, you know, something like historic knuckleheads and stuff like that. And I've done many, and I work, I'm not a good welder, really experienced welder, and the reason for that is there's the Hanford Nuclear Reservation here that has the best welders in the world. They better be. Okay, so, and they are. And there's an art to welding old sand cast like this. And I'll quickly explain some things here. What's missing here is there should be a coating in here. It's called Gliptol. And there's some metal primers that you can use too that are good enough if you do a good enough surface prep. But Gliptol was what's used, kind of a reddish. And since these were sand cast, they would glip tall all these surfaces in here. I think they usually left the transmission to eat itself up. But in the motor here, they would glip tall it to keep sand from falling into the oil system and scoring up your crank pins and these bearings. And it's a reality because dozens and dozens of old engines that I've done that are not glip-talled, you can see a foggy appearance on the bearing surfaces. And I'm not kidding you. I've seen a lot of it. So this type of case here, the unit construction, I face these using a fly cutter, okay, because a good size fly cutter. It's even over there, kind of down by the wrenches there. So I don't know, 5 inches in diameter, but I can cover with the movements on the jig bore, and the jig bore is superior to for fly cutting because it's a single point tool and the machine is always level. You know, it's more level than you can adjust a head on this thing or a regular vertical mill, and it's solid. You know, it's no flex like to deal with and stuff. So to face that, I built this bar here. And to face big twin engines and stuff, they're just over 12 inches total of what you got to face. It's got a little bit of offset there and stuff. So this is what I did, how I did it, and you can get these interfaces as flat as you possibly can. You know, it's just very important, all of them. And I mentioned before that the Sportster K to XR750, that the engine is a stressed member of the frame. And it just causes all kinds of twist on this stuff. And even in the best case scenario, these cases are warped. And I've been in accidents and stuff like that. You know, you got to check it out, you know. And one of the things that I find kind of funny is, you know, this thing here would be in the thousands of dollars. And I will fix this. It just costs too much to pay somebody $100 an hour to put this together. Years ago on the internet, here's an old guy way back 20 years ago, went by Hack a Saw. And he built these cool bikes. And he usually used like old big twin flathead engines and stuff like that. And he made a comment that's true. And I was bantering back and forth on it. And I mentioned back in the 80s, book time to rebuild a Harley Davidson engine in the shop, in the Harley Davidson dealership. You have the engine sitting on the bench. You got 8 hours. You know, but you take something like a antique motorcycle like this, you're talking 60 to 100 hours. And this is a little bit low on my priority list, but I'm going to get around to it. I have a 6,000 pound radial drill that's in just very good condition that I got tarped up out there. It's doing just fine. That I got to deal with first, and that's my last big project. I kind of overdid it on projects for myself. This milling machine, the axle son, and that big drill was just huge projects, just requiring just a whole bunch of time. The radial drill, I actually got 200 hours in it so far, and it's just going to be a stunning machine when I'm done. It's like new, but it was abandoned and had some damage to it. So anyway, back to this stuff. So this is UPA-5 wall hopter, and it came off a SIP jig bore. And you can even see down here where it's written jig bore. These cost $10,000, and but not this one. This one here, it's got a Boeing control number on it. I bought it at the Boeing surplus store back early 90s and stuff. I think it's closed now. So anyway, I can quickly face these cases, line them up, both big twin and little twin, and machine anything on those things. So you can weld them up. I can put them on here and machine them using this and that. Okay, now there's another head here, and it's got to be 30 pounds. Huh? Oh, that's not that much. 25, 20 pounds. I don't know. Right here. Now, these things aren't cheap. You know, this is a very hard thing to find, and it's just so extremely useful. So this is a tree angle cutting head, and that's the Moore shank on it. And this you can use in a Bridgeport, but it performs much better in a jig bore, I'll tell you that. So when you hold this collar here, you see this collar spins? Then it feeds that little dovetail there, and this rotates, see? You can have it, you can make it so it faces. It's got this tapered hub, and you put these tools in it. You can put lathe bits in, and I've got some custom ones I made that work better for me. Like the wall hopter head. It comes in a kit, but for what my purposes, everything I did I had to make custom. Like that heavy bar, this here. So this is the bar that fits into the wallie right there. Okay. So we're back to this. Well, one of the things I did with this on the Harleys, this was most useful on two-stroke cylinder heads. I also did work for the Honda shop, KTM dealer, all those people. So these things go on there, and you can put this in a hole, and you can cut a snap ring groove in your milling machine down in a hole with this. And what I used this for was repair of the left Timken bearing. Okay? So this is an industrial solution to a motorcycle. Heavy industrial. I mean, this is quite an investment. It really is. But I want to point out that I had a commercial shop. You know, I worked on Harley Davidson engines, and when I quit working on the bikes because of that insurance situation, and that's a whole thing. It's dealing with the general public. It's really a bad idea. The best thing to do as a machinist is to deal with businesses, deal with the Honda shop, see what they need. You find out what they need at the Harley shop, which is not much or nothing, because the situation's changed. Everything, the technicians there just change things, you know. And to get horsepower out of motors and stuff, it's like that Dodge Demon that has 1,000 horsepower. Well, that's right from the factory. And that's an engine that not everybody can work on, or why would they? You know, there's, I think the Car Wizard or something did that and stuff. But Harley Davidson's the same way now. They got stage 1, stage 2. You got these kits that these people have enough education and training to install these new parts on new engines, okay? Then they could get well over 100 horsepower on brand new Harley Davidson engines, you know? And when we're talking these antique engines, don't do it. You know, you really shouldn't. And if you want a hot vintage motor, use S&S components. It's just a lot wiser because they're built up and stuff like that. Aftermarket components, you know, other than antique, fragile sand castings, you know, I don't know, I can get into some things that I could advise somebody working on this stuff to stay out of trouble, you know, doing stuff. The customer in the Harley Davidson situation. Now I'm looking at it from a business point of view. Usually, 90% of the time in Harley Davidson, the customer is never right. You know, you got to be careful not to sell them stuff that they see advertised that you know it's not going to work, and you can lose money that way, but you can lose in a lot of other ways. You get yourself sued doing stuff that doesn't work. Okay, I'm going to be back. I'm going to show you some stuff about fixturing. Alrighty, this is what I use for a lathe to make the fixtures I'm going to show you, okay? That's why I have this. And we will get over there in a second. Yeah, well, before the days of jigboring machines, this was a way that it had to be done for some operations. And what this is a lathe faceplate, and it's a donation from Warren. I really appreciate the donation, Warren and everybody, Corey and Mel. They make this possible. They really do. It kind of keeps me going as an old person goofing around with this stuff. And there are many ways to do things, and I never felt that there were really secrets. Okay, now some of this is a combination of things that I picked up at the factory in the old Juneau developmental area. They had some kind of cool stuff going there. They had some old new shovel head engines, and they put plexiglass windows in it so they could watch the oil circulation in them. And that's a real problem, particularly in shovel heads, and I'll probably get into that. It might be enlightening. Not all problems can be solved, but it helps if you're aware of them. Okay, so this could also be a rotary table, and that's what I mounted this thing on. And this does a lot more than motorcycle work. It holds all kinds of things. I could even hook a chuck on here. Like I say, I most often have this on a rotary table, a horizontal, vertical, 10-inch rotary table. So this, if you're familiar with the lapping tool, this is similar to the lapping tool guide that holds that guides the lapping tool through the left bearing. Now on K models, Sportsters, and stuff like that, the main bearings are Timken, and on racing models they're ball bearing. So that's a different thing going on totally. So this is it uses a Timken bearing set, dual Timken bearings. Comes with the cones and the races. See, one of the races is lost somewhere around here. Then here's the spacer. So the outer races here press into the engine crankcase against the snap ring, and that can get destroyed, and you can fix it with the wall hopper or the tree head, recutting that groove, okay, or creating a new whole new insert for the left main bearing. So these press in the case against a snap ring like that. Then both bearings come in like this, and here's the spacer, and this comes in different thicknesses. Now generally, in the instructions in pairs of Timken bearings like that, they warn you, do not mix any components of this thing. But in practice, you have to, because there's some inaccuracies in these Harley engines that are like the press fit of these races. If it's tighter than normal, then you'll need a thicker spacer. So Harley provides these spacers in different thicknesses. And the way I solved not having these spacers, just, because the in-play is like between 1 and 4 thousandths is recommended on a Sportster anyway, and 4 thousandths is ridiculous. So, you want to get the in-play within a thousandths, right? And you have hundreds of these things. Well, what I do, I buy 3 sizes of them, then final size them with a surface grinder. That's how I solved all the spacer problems. I wouldn't have to have different size spacers. Some of them, it might be 10 sizes in 10 different spaces and thousands sizes and stuff. You just buy 3 of them within the range is what I did, and then grind them to fit. And then every time, you're building an engine stuff, you're in total control of the fit, having a surface grinder. So, okay, so the left bearing, it's very difficult. You can see the shape of these cases here to fixture them, and how to do it accurately. They fixtured them at the factory. They lined them up with that rear cylinder surface, and that's a good thing to do for consistency. And you don't hold these oddball engines by the motor mounts. That's not a good idea. You want to fixture it by the main bearing, okay? So this is a real tight fit. Here, see if I can squeeze it down in there. It floats. So the K's will have these in it like that. And you slip the case over here. Then you put the other bearing on. All right, you got the case in there now. And then you don't need this. You don't need the spacer. And that's how you locate, or how I locate, how the factory locates the engine cases when they machined them. Some of it. But they did, you don't have to use bearings. You can cut cones, just steel, and do it that way too. You can just make a fixture that'll pull that case down. Now, you have this on a horizontal vertical rotary table. So you can flip the table to vertical, and then put both cases on it. And then I've showed a little bit of that. I think I got a photo or two I'll put out there. And then you can machine the cylinder mount surfaces to exact from the center. I mean, everything will be exactly square without screwing around. You know, it's just automatic. You rotate it over to the degree that the surface is, different surfaces are. And that's how I fixtured those engines. Okay, I'll be back. All right, I thought I'd mention a little bit more on this fixturing here with the K model XL type cases. With a 10-inch horizontal vertical rotary table, you can have this in the vertical position, and there's enough space to rotate to do the cylinder surfaces here, where you have to rebore these, like if you're doing big bore or something like that, or surfacing that's going to need to be done on here accurately, you know, and exactly, because you're holding, fixturing the case by the main bearing. So you get on the rotary table, you'll pull that bearing, the whole thing down, and I think I used a cap, I don't know where that was, but you can put anything across here, then pull it back with a bolt from behind. There's a hole through the rotary table, and just like there's a hole through the spindle of a lathe. So you pull it back here, and that helps lock it down. Then you come around and do some other clamping, you know, carefully clamping the cases, but the locating is best done there. Now, in the Harley Davidson racing department, which was very inactive in 1981, they had two Bridgeport milling machines, and they had rotary tables fixtured like this, that they built those 750 cc race engines with. So they didn't have a whole lot in there, but they had two brand new Bridgeports and an old South Bend lathe and a really kind of interesting shop-made flow bench. All right, so I hope you can kind of get the idea. Right, for the XL, it has to be a smaller one of these, and for K models and whatever. And if it's a racing engine, you have to build a custom because they're ball bearing. Okay. With the jig bore compared to a regular vertical mill, there's one important but small, and you wouldn't believe how important it is until you start doing stuff like this on a Bridgeport or a standard vertical mill versus the jig boring machine. And the problem with the regular milling machines is when you're doing precision boring and stuff with like this jig bore, you want to use dial bore gauges. Now, that's truth or consequences right there. You can't fool yourself with these. So you're doing these holes, and the measuring, you can see that you have to get the head out of the way to get this in the hole. Now, with a regular milling machine, you have to either move the table or crank the knee down, and it's not going to exactly come back. So the jig bore does that. It comes back exactly. If you put the right torque, the same torque on the lock, you can move this head anywhere, and it stays in line within 1/10,000th of an inch. And that's the specification of this, actually 80 millionths. So when you're punching holes, this head cranks up with a chain. It's not geared or anything, and it doesn't automatically feed down. You loosen the lock and use that big spider wheel, and there's a big counterbalance. So it's real easy to move the head up and down. So when you're boring a hole and you're sneaking, you're trying to get a good tolerance on it, it makes it a lot easier if you can get that head out of the way. It's so quick, and then gauge the hole, drop the head back down, and finish your hole accurately. And that's and keeping the location perfect. That's why these are kind of specialized. And like I say, they're really lousy for milling. And these things, you might find this interesting too, is there's no spindle lock on these. This quill is so accurately fit to the bearings in here, and they're actually big brass bushings that the quill's in. A lock would deflect it. That's how accurate this thing is. So you can fix the spindle in position using this really odd snail. See that? The snail? Look at that. So that's a stop, and it rotates. See the distance of the quill travel. The quill travel is identical to a Bridgeport at an irritating 5 inches. So you're not going to gain a thing there. But you can pick up boring a hole. If you run out of that 5, you can re-pick it up by lowering the head and picking it up. The machine's so accurate, but it leaves a mark. But that's okay if you're going to finish stuff on the Sun and Hone. Another specialty thing. Now, I'll get into cylinder heads at some point, probably. I don't know. Cylinder heads can be pretty irritating. But this machine can be utilized for cylinder heads. I think I mentioned 2-stroke heads, but you can also face cylinder heads with the wall hopper very quickly and very accurately, and it leaves a lathe-like finish instead of that fly cut. Okay, I will be back. Well, I hope you enjoyed this episode of Harley Davidson Machine Shop. Now, one of the things about working on these things is non-destructive practices. And one of the things that can happen with these crankshafts, and I'm going to say particularly with custom crankshafts have a lot of torque on them, is causing damage to them, disassembling them. And the machinist will know these things, but the motorcycle mechanic may not. And there's some misleading photos and things like that in the old manuals. Okay, have a good day.